the others have been referring to. And I'll be talking to 5 tools. One is sort of a spin-off on the agriculture water demand model. It says agriculture, but when you're done, you'll see it does a whole bunch more than just agriculture as well. So these tools are, some of them are relatively simple, 2 of them. You can use them yourself. You can go home tonight and actually get into the tool and use them. You'll see that they're actually quite neat in what some of the things they do if you want to get answers on water management, water conservation, things like that. I'll start with the water balance model. This is a tool that we started working on about 4 or 5 years ago. The water balance model is a web-based tool, and basically what it does is this. If you're going to develop land and you're going to do a green development, how do you know that what you're putting on the ground is the right thing? What is the change in the rainwater management that you're seeing on the ground? It's easy to say we should do these things. When we were looking at this 5 years ago, what we wanted is a tool that can do an assessment about how well we're doing on the ground, because in the end, that's going to convince local governments and people to make a change. So the water balance model is a tool that you can enter in a bunch of information and see how you're capturing your rainwater on site. It integrates the site with the watershed and with the stream. It sets performance targets, so a local government can sort of say, this is the natural condition we have now. You are going to put this development in. We want the rainwater coming off the site after you develop to be no more than X% higher than it is today, or we want it to be the same, and set those targets. A person can go into the water balance model, run it, and then actually see if you're achieving those targets or not. So it's a really useful tool for local government. Now, one of the key things when you start talking about developments, you're always changing from soil-based things, which is the natural landscape, into hardscapes, rooftops, parking lots, things that don't let water go back into the ground. So really, a real key understanding is how does the water move through soil? How do we capture the water? How does it get stored? How does it get replenished to groundwater? And one of the key things, this is Richard Rose from North Vancouver, who's the co-chair of the Water Balance Model team. One of the key things that we found is that the things that we do in the wintertime, putting in the soils, capturing the rainfall, having it go back to ground rather than having it run off the site, eroding the streams, all those kind of things, is also the same kind of a strategy that we would like to have for water conservation in the summertime. Putting in that topsoil allows your roots to go deeper, allows the grass to grow thicker, means less water, less irrigation. It's a water conservation tool. In fact, the #1 thing that any community can do to save water during the summer months is to put in a foot of topsoil. Bar none. Doesn't matter what else you do, put in the topsoil, you will save a lot of water. And it's getting that message across that a tool like the water balance model can demonstrate. So, where and how the land is developed determines how water is going to be used, how sustainable water supplies are. How water runs off the land impacts the aquatic habitat. If we have the water running off the storm sewers and off the parking lots quickly, we scour the streams, we create sediments, we impact the fish habitat, all those kind of things. Look at the development in the 1950s, and this is some work that Richard's doing in North Vancouver. Back in the 1950s, 53% of the lot was in the tree canopy, 19% was hard surface, 13% was the building footprint, 15% was landscape. If we move ahead to the 1990s, that changed to 24% being the building footprint, 25% hard surfaces, 28% landscaping, 23% tree canopy, and that's usually only if you were close to a creek that had a covenant on it. So we had 49% in hard surfaces. When you run the water balance model, it gives an output. It tells you how much of the annual rainfall is going to run off the site. The graph there, #1, was runoff from a 1950s development. This one here is the runoff from a 1990s development, almost twice as much. If you start putting in the source controls, like infiltration basins, pervious pavers, landscaping, topsoil, do all those things in your development site, in a 1990s development with source controls, we can get back to 1950s levels or even better. And this is the quick kind of an output that the water balance model gives you after you put your data in. You can get an answer very quickly about what you're doing on a site. And this is why quite a few of our partners, which are local governments, are now starting to say to developers, look, we want you to run the tool, we want you to demonstrate to us that your development is going to be green, it's not going to impact on our stormwater and our creeks and rivers.